For more than 70 years, a mysterious set of astronomical observations has lingered in the background of scientific discussion, largely forgotten except by a small circle of researchers who are fascinated by unexplained phenomena. These observations originated at the Palomar Observatory in California during the early and mid-20th century, when astronomers captured thousands of photographic plates while surveying the night sky. Among those plates were a number of curious, star-like flashes, brief, luminous points of light that appeared suddenly and then vanished within the span of an hour. At the time, astronomers had no compelling explanation for them. Satellites had not yet been invented. Airplanes did not fly at the altitudes necessary to create such effects, and the observational technology of the era was limited in its ability to track fast events. For decades, these intriguing flashes remained unsolved anomalies. Now, two new peer-reviewed papers have revived interest in these historical observations and have brought them back into scientific debate. The researchers behind these papers argue that the flashes, known as transients, may represent something far more unusual than previously thought. The new research re-examines the original Palomar sky plates with modern analytical methods and more advanced digital tools. According to the authors, these transients occurred on or near the dates of several Cold War nuclear weapons tests. Even more intriguingly, the dates also coincide with periods when historical UFO reports surged. The authors suggest there may be a statistical correlation between the three phenomena: nuclear testing, spikes in UFO sightings, and these unexplained flashes captured on Palomar film. The idea that unrelated events from astronomy, military history, and public reports might converge is provocative, and it invites speculation about whether all three could be connected through some unknown mechanism. Could the flashes be artificial objects observing Earth? Could they be misinterpreted natural phenomena? Or could the coinciding dates simply be a remarkable coincidence? The researchers themselves claim they don't yet have definitive answers, but they argue the correlation is strong enough to warrant further scientific investigation. These flashes, or transients, are not entirely unprecedented in astronomy. The night sky is filled with objects that brighten and fade, including variable stars, novae, supernovae, meteors, and cosmic rays. Camera defects and atmospheric distortions can also create misleading marks on photographic plates. However, what makes the Palomar events particularly compelling is that some of them exhibit patterns and shapes that do not match known natural causes. The new papers identify several transients that appear as sharp, point-like lights arranged in unusually straight lines or rows, patterns that the authors argue do not resemble meteors, stars, or typical photographic artifacts. Moreover, these objects appeared and disappeared too quickly to be standard variable stars. Their sudden appearance, bright illumination, and rapid disappearance suggest a phenomenon that is not easily explained by the typical events that astronomers are accustomed to analyzing. Study co-author Stephen Brule, an anesthesiologist from Vanderbilt University, who has developed a strong interest in UFO research, states that the team's analysis has eliminated many of the common explanations. He argues that the remaining possibilities include artificial objects reflecting sunlight in orbit, objects that would have existed before the Soviet Union launched Sputnik 1 in 1957, the first recognized human-made satellite. If these flashes were caused by artificial objects, and if those objects were indeed in orbit before the dawn of the space age, it raises profound questions about their origin. Who or what placed them there? Why would they appear around the time of nuclear weapons tests? Were they observing Earth? Were they responding to some human activity? Or were their appearances incidental? Brule emphasizes that while these possibilities may sound extraordinary, the scientific process requires exploring every plausible explanation once conventional explanations have been ruled out. His co-author, astronomer Beatrice Villaroel from the Nordic Institute for Theoretical Physics in Sweden, has spent years studying archival astronomical data, particularly photographic plates from the mid-20th century. She is known for identifying unusual patterns or inconsistencies in old astronomical images that modern surveys might overlook. Her expertise lends a level of credibility to the analysis, even though she and Brule acknowledge that the interpretations remain speculative. Their argument is not that the flashes definitely represent extraterrestrial technology, but that they deserve serious scientific attention rather than dismissal. Not everyone in the scientific community agrees with the conclusions of the new papers. Some astrophysicists warn that the original photographic plates were taken with early observational tools that lacked the precision and consistency of modern digital telescopes. Michael Garrett, director of the Jodrell Bank Center for Astrophysics at the University of Manchester, expressed admiration for the creativity and initiative shown by Villarroel's team in using archival data. However, he also warned that the quality of the data presents significant obstacles. Before Sputnik and the era of well-documented satellite tracking, astronomical images were not produced with the same calibration standards or documentation found in modern observatories. Variations in chemical processing, exposure times, atmospheric conditions, and plate handling could all introduce artifacts that resemble astronomical objects, but are not actually present in the sky. Garrett also raised concerns about the historical UFO reports used in the analysis. While the papers attempt to correlate the timing of the Palomar flashes with spikes in UFO sightings, the reliability of those reports is questionable. Many are anecdotal, lacking verifiable evidence or consistent documentation. Villarroel's team includes a disclaimer acknowledging that they did not evaluate the validity of the historical UFO accounts they referenced. Without confirming whether the UFO reports are accurate, scientifically meaningful comparisons become much harder to establish. Correlations might appear statistically significant on paper, while still being based on unreliable or inconsistent data. Another critical challenge is the limited nature of photographic plate data itself. The sky plates capture only a tiny fraction of the sky at any given moment, and even when an unexplained flash does appear, the data often lack follow-up observations. Without consecutive images or multiple perspectives, astronomers struggle to determine whether a flash was caused by a fast-moving object, a brief reflection, a chemical irregularity on the plate surface, or an actual celestial phenomenon. The absence of multiple frames documenting the same event means researchers cannot reconstruct trajectory, origin, or duration with confidence. In many ways, the Palomar transients are snapshots, single-moment interpretations that may or may not accurately depict what was truly happening in the sky. Nonetheless, the new research has invigorated discussion in both scientific and public communities. Some see the flashes as potential evidence of previously unknown orbital technology, possibly placed by advanced civilizations observing Earth. Others interpret the patterns as early signs of Cold War surveillance experiments that remain classified. A subset of researchers propose natural explanations, such as unknown atmospheric phenomena or rare meteor events, which could mimic the appearance of artificial lights. There are also skeptics who argue that the entire pattern results from human biases, an eagerness to connect unrelated events in ways that support dramatic narratives. The significance of the transients is not confined to the question of extraterrestrial visitors or hidden human technology. The research also highlights the immense value of historical astronomical archives. Thousands of photographic plates taken in the early 20th century contain information about the universe that may no longer be visible today. Some stars have exploded, faded, or shifted. Some objects may have passed through the solar system unnoticed. By digitizing and analyzing these plates, scientists gain a rare window into a period of cosmic history that modern instruments cannot recreate. Whether or not the transients represent something extraordinary, they underscore the importance of preserving and studying old astronomical data with fresh eyes. At the same time, the debate surrounding these papers reflects a broader tension in science, the balance between skepticism and open-minded inquiry. Extraordinary claims require extraordinary evidence, yet scientific progress often begins with unusual observations that challenge existing assumptions. Researchers must tread carefully, neither dismissing anomalies outright nor leaping to conclusions that the data cannot support. The Palomar transients sit at this delicate intersection. They are intriguing enough to merit investigation, but ambiguous enough to raise doubts. Some scientists argue that the field needs more structured ways of studying historical anomalies, including standardized methods for analyzing old photographic plates and clear protocols for assessing correlations with non-astronomical datasets. As the controversy unfolds, the authors of the papers encourage more observatories and researchers to re-examine their own archival collections. They believe that if similar transients appear in other historical datasets, it could strengthen the case that these objects represent a real phenomenon rather than isolated photographic artifacts. Conversely, if no similar patterns appear elsewhere, it might point toward issues unique to the Palomar plates themselves. Several astronomical institutions have expressed interest in conducting follow-up studies, potentially comparing mid-century plates from Europe, South America, and Africa to determine whether unexplained flashes appear in those records as well.